Hello everyone, welcome to complete lecture series on M3 subject. For more videos, check in my playlist. So in my today's video, I'm going to explain to you all particular integral for hyperbolic function. For hyperbolic function, about trigonometry function, I already explained in my previous lectures. So in our today's lecture, we are going to learn how to find particular integral using hyperbolic for hyperbolic function, using short trick. Okay, we are going through the short trick and at the end we go for finding the particular integral. Okay, now whenever I say hyperbolic function, which is the first thing comes front of our eyes, which is like a cos, then hyperbolic, and then some of the functions. Okay, that means when we extend trigonometric function, we get the hyperbolic. Okay, like see that hyperbolic function means which has cos hyperbolic x, okay, sine hyperbolic x. These are the hyperbolic function. So if you want to learn more about hyperbolic function, check in my playlist. Okay, so here, so if we have the function, just I consider this one as a single variable function, but maybe it is like ax plus b, x square plus bx plus c. In such a case, if we have hyperbolic function, okay, let me explain here the condition. It is our maybe third condition. When we have phi of x, okay, when we have phi of x, that means right hand side of our given linear differential equation, when phi of x is like a sine hyperbolic ax plus b or cos hyperbolic ax plus b, okay, in this condition, in this case. Okay, so how can we find the particular integral for this hyperbolic function? Now see that one thing we need to keep in mind, the standard form of a particular integral. So particular integral can be written as 1 upon f of d into phi of x. Okay, 1 upon f of d into phi of x. This one is our required particular integral. Okay, so we have to modify this particular integral with perspective of this phi of x, sine hyperbolic x plus b or cos hyperbolic ax plus b. Okay, now we are going to replace some of the values here, so it is little adjustment. Okay, so when we have trigonometry function, we always consider d square. Okay, we always consider d square, so whether it is a trigonometric or whether it is a hyperbolic, so replace d square instead of d here. Okay, yes, so phi of x, we are going to consider phi of x one of this or this one. Okay, so how we are getting particular integral here? Particular integral can be written as 1 upon f of d square, which is the left hand side of our given linear differential equation, and phi of x, it is the right hand side, which is a sine hyperbolic ax plus b or cos, you may consider anything. Okay, sine hyperbolic ax plus b. Okay, so this one is our required particular integral and we have to solve this one further. Okay, we have to solve this one further. In the form of a trigonometric function, we consider d square as a minus a square. Okay, we consider d square as a minus a square instead here. Okay, but now in the form of a hyperbolic function, just remember, we are going to replace d square as only a square. We are going to replace d square as only the a square, and then you will get the required particular integral. Okay, that means we write 1 upon f of a square into sine of hyperbolic ax plus b. Okay, sine hyperbolic ax plus b. So this one is our required particular integral. Okay, so you have to solve it further. But now see that we have similar condition like a trigonometric or similar condition like a regular exponential function. So what happens if f of a square goes to 0? Okay, that means which implies f of a square provide not equal to 0. Okay, so what happens if it goes to 0? Let me write the first case here. When f of a square, which is a 0, whenever f of a square which is 0, simply apply similar condition like our exponential or trigonometric function, multiply numerator to the x and differentiate denominator. Okay, so we write a particular integral whenever f of a square it goes to 0. For this function, we define multiply numerator to the x, we multiply numerator to the x and differentiate denominator f dash of a square, okay, and replace the value of a square sine hyperbolic ax plus b, provided f dash of a square need to be not equal to 0. Okay, this condition has to be there. But what happen if f dash of a square it also goes to 0? Then we arise here another second condition. Okay, so we write a particular integral, again multiply numerator to the x and differentiate denominator one more time. That means x multiplied by x, which is x square, differentiate denominator again one more times f dash of a square and the sine of hyperbolic ax plus b. Similar process you have to apply as we applied in a regular trigonometric or exponential function. Okay, so this one is our third condition for a hyperbolic function, and using this condition we are going to solve the particular integral. Okay, now let's solve one of the important question which asked in your previous year university SPPU question paper. Okay, yes, let me write the example. So I'm going to consider one example here. So what happened once we solve one of the example, your concept will be clear. Okay, so solve for, that means we have to find out the complete general solution. Okay, I'm going to write GS. Okay, we want here complete general solution or complete solution for our linear differential equation. So I'm going to consider linear differential equation as a d cube y by dx cube. Okay, d cube y by dx cube minus 4 times dy by dx, which is equal to 2 cos hyperbolic 2x. Okay, 2 cos hyperbolic 2x. Now see that we have one of the side which present hyperbolic function and the remaining one it is nth order differential equation. Okay, yes, now first of all go for finding it's a complementary function. As you all are familiar with the complementary function, I explained so many times. Okay, so first of all auxiliary equation. What is the auxiliary equation? So what is the auxiliary equation? D cube. Okay, so I'm going to write auxiliary equation d cube. Okay, as we have d by dx as a capital D, so d cube by y by dx cube is capital D cube minus 4 times dy by dx minus 4d into y, which is equal to 2 cos hyperbolic 2x. Okay, so how we write auxiliary equation? We write d cube minus 4d, which is equal to 0. Okay, so d cube minus 4d, which is equal to 0. Now see that we want one of the root. Whenever we have one of the constant 0, that means whenever we have constant absent in our cubic term, so consider d as a 0, one of the root. Okay, so how we take d common from here, so left here with the value d square minus 4, which is equal to 0. So multiplication of 2 bracket goes to 0, that means d is a 0 and d square minus 4, which is equal to 0. This implies d square, which is equal to 4. This gives d square, which is equal to 2 square, and this is the value for d is a plus minus 2. Okay, now see that we got the 3 roots for our cubic auxiliary equation, which is one of the d is 0, d plus 2 and minus 2. Okay, 0 plus 2 and a minus 2. All roots are here. For complementary function we have to write out the solution. That means we have here all roots are real and distinct, and whenever we have roots are real and distinct, then we write solution. Okay, it's a complementary function or solution y of x as a c1 e to the power m1x, write down 0x, plus c2 e to the power 2x plus c3 e to the power minus 2x. Okay, this one is your required complementary function. Okay, that you can do, it is easier. Now it is main task here for finding the particular integral using our given standard form. Okay, so we are going to find particular integral here. Okay, let's get started. Particular integral. Okay, yes, so here we can see we have the function for particular integral 2 cos hyperbolic 2x. Okay, yes, so particular integral for hyperbolic function. How can we write the particular integral for hyperbolic function? We write 1 upon f of d into phi of x as a 1 upon f of d square into phi of x. Okay, so particular integral I am going to write as a 1 upon f of d square. Okay, 1 upon f of d square into phi of x. This one is our particular integral that we learned already in previous condition. Okay, so 1 upon f of d square. F of d square, that means auxiliary equation, that is a d into d square minus 4. Okay, which is in our question given already. Okay, and phi of x means other right hand side of our given linear differential equation, which is 2 cos hyperbolic 2x. This one is a right hand side for our given differential equation. Okay, now see that we have 1 upon d into d square minus 4. That means d, which is repeated twice. Okay, that means take the power wherever we have less. Okay, wherever we found less power of a d, take it to the that phi of x. Okay, so that means how I'm going to write it here, d square minus 4 and 1 upon d take with a 2 cos hyperbolic 2x. Okay, yes, so what I have done, I just taken that d along with this one. Okay, so we have to convert this term in the form of a d square. Okay, so whenever you get the d square only, you can replace only as the a. Okay, that means 2 as a d square. Okay, that means 2 d square is equal to 2, that means d square which is equal to 4 square. Okay, so we know that standard result 1 upon d into phi of x can be written as integration of a phi of x dx. Okay, this one is the standard result. That means 1 upon d means it is the inverse of a integration. Okay, so that means we can take the integration directly. So 1 upon d can be vanishes from here. Okay, 1 upon d square minus 4 keep as it is here. Now integration of 2 cos hyperbolic 2x, 2 cos hyperbolic 2x. Okay, dx, 2 cos hyperbolic 2x dx. So for integration of a hyperbolic function, already I explained similar concept in my channel. Okay, yes, so it's not that difficult. If you want, you can see these videos from my channel. So keep 1 upon d square minus 4 as it is. Okay, d square minus 4 as it is. Integration of 2 cos hyperbolic 2x. Now 2 keep as it is constant. Cos hyperbolic x has a integration sine hyperbolic x. Okay, that means sine hyperbolic 2x. Okay, integration of cos hyperbolic 2x, which is sine hyperbolic 2x. Okay, and divided by that 2x need to here we are going to write a differentiation of 2x, which is a 2. Okay, and this bracket complete. This one is a required complete integration, so 2 get cancelled with the 2. So we left here with the value 1 upon d square minus 4. Okay, under bracket sine hyperbolic 2x. Okay, yes, you can see that 1 upon d square minus 4 sine hyperbolic 2x, we have here the value. Okay, yes, and now what we are going to do, we are going to replace sine hyperbolic ax plus b, that means a as a 2 here. Okay, so d square which is equal to a square, that means you have to replace a as a 2. So what we have here, a which is equal to 2, then a square become 4. Okay, and we know that d square can be written as a square, means d square is having value 4. Okay, yes, so now we are going to substitute value here. D square as a square is a 4 minus 4. Now see that a denominator, it approaches to 0, and whenever denominator approaches to 0, we know that we multiply numerator to the x and denominator to the, take the differentiation of denominator. Okay, so sine hyperbolic 2x. Okay, so that term can be defined later on. Okay, so that's why we are going to extend our particular integral. Okay, we are going to extend particular integral from where, from here itself. Okay, here itself. So differentiate denominator first, multiply numerator to the x multiplied by 1. Okay, so we are going to change it here only. Okay, we are going to change it into this step. So 1 multiplied by x, and total denominator d square is having differentiation 2 times d minus 4 constant, it goes to 0. Okay, and sine hyperbolic 2x, sine hyperbolic 2x. Okay, yes, now try replace the value for a as a, but now see that as we have denominator d, but in our given condition, it says that d square only replaced by a square, but that means there is no any value to replace d. there is no any value to replace d. So what we do, we are going to multiply d to the numerator and d to the denominator. So we are going to write x multiplied by d divided by 2d square. Okay, d multiplied to the numerator and d multiplied to the denominator, and the sine hyperbolic 2x. Okay, yes. So replace now d square as a square, as we have a which is equal to 2. Okay, then d square which is equal to a square which is equal to 4. Okay, replace d square as a 4. Okay, then we are going to write x multiplied by d divided by 2d square. So 4 multiplied by 2. Okay, under bracket sine hyperbolic 2x. Okay, d into sine hyperbolic 2x means d is here as a d by dx. Okay, that means we have to differentiate this term. So x divided by 8 multiplied by differentiation of this term with respect to x. So sine hyperbolic 2x has differentiation cos hyperbolic 2x multiplied by differentiation of 2x which is a 2 here. Okay, yes. So 2 1s are 2, 2 4s are 8. Okay, so we are going to write it's a particular integral as, okay, x divided by 4 under bracket cos hyperbolic 2x, cos hyperbolic 2x. Okay, yes, this one is our required particular integral. Okay, this one is our required particular integral. So already we know that the complementary function, add complementary function plus particular integral, add complementary function plus particular integral, you will get the complete, okay, complete solution. You will get the complete solution. Okay, so put these values here, you will get the required answer. Okay, now see that this is our complete solution for the example. Okay, so I hope you all have understood my entire solution. It's nothing difficult here, just need to apply the similar process everywhere. This is the nice thing about these examples. You need to understand the posture of our example, what are the format behind of the solution. Just try to understand it. At the end you will get the correct answer. Now see that such a questions coming for 4 marks. 4 marks. Okay, important questions. Such types of the questions are important for SPPU. Okay, so you must have to be ready with such example. These are very much easier. But even after, if you found anything difficult, confusing or challenging, let me know in my comment section. I will come up with the more videos. I already uploaded plenty of the videos in my channel. So if you want more videos like a similar topic, so if you have anything doubt, difficulty from your GATE question papers, or if you come across any challenging part in mathematics, just let me know in my comment section, guys. I would be love to solve these questions. Okay, so I hope you all have understood my today's session. So thank you everyone. Thank you for my today's lecture.